Aluminum entry wiring is currently not permitted for use in new residential construction within the United States. The National Electrical Code, referred to as the NEC, has effectively prohibited its use for such applications since the 1970s. This decision stems from significant safety concerns that arose due to the inherent properties and performance characteristics of aluminum when used as a conductor in residential electrical systems. The primary reason for this ban revolves around the increased risk of overheating associated with aluminum wiring compared to copper wiring, which is now the standard material used. Overheating in electrical wiring can lead to a range of problems, the most serious of which is the potential for electrical fires. Aluminum has a higher coefficient of thermal expansion than copper. This means that aluminum expands and contracts more with changes in temperature. In electrical connections, such as those found at outlets, switches, and circuit breakers, this expansion and contraction can lead to loosening of the connections over time. Loose connections increase electrical resistance, which in turn generates more heat. This creates a dangerous cycle where the heat further degrades the connection, leading to even more heat and potentially sparking a fire. Copper, with its lower coefficient of thermal expansion, maintains a tighter connection, reducing the risk of overheating and subsequent fire hazards. Another factor contributing to the safety concerns surrounding aluminum wiring is its susceptibility to corrosion. Aluminum is prone to oxidation when exposed to air, forming a layer of aluminum oxide on its surface. This oxide layer is non-conductive, which means it interferes with the flow of electricity. While all metals corrode to some degree, the nature of aluminum corrosion poses a particular problem in electrical connections. The aluminum oxide layer increases the resistance at the connection point, leading to heat buildup. Furthermore, if moisture is present, electrolytic corrosion can occur, which further degrades the aluminum conductor. Copper, on the other hand, forms a conductive oxide layer, which does not impede the flow of electricity to the same extent. The combination of a high coefficient of thermal expansion and a greater susceptibility to corrosion makes aluminum wiring less reliable and more prone to failure than copper wiring. These factors significantly increase the risk of electrical fires in homes wired with aluminum. The NEC recognized these dangers and, through revisions and updates to the code, effectively banned the use of aluminum wiring in new residential construction. The code now mandates the use of copper or copper-clad aluminum wiring for most residential applications. While aluminum wiring is no longer permitted in new residential construction, many older homes still have aluminum wiring installed. If a home was built in the 1960s or 1970s, it is possible that it has aluminum wiring. It is important to note that simply replacing the aluminum wiring with copper wiring is not always the best solution. This is because the electrical system in a home is designed as a whole, and replacing only some of the wiring can create imbalances and potential problems. There are several options for addressing aluminum wiring in existing homes. Firstly, a qualified electrician can inspect the wiring and make recommendations for improving its safety. This may involve tightening connections, replacing damaged wiring, or installing special connectors that are designed for use with aluminum wiring. These connectors, often called coupling connectors, are designed to create a secure and reliable connection between aluminum and copper wiring, reducing the risk of overheating and corrosion. Secondly, another option is to install arc fault circuit interrupters, called ASICs, on circuits with aluminum wiring. ASICs are designed to detect arc faults, which are a common cause of electrical fires. When an ASIC detects an arc fault, it will trip the circuit breaker, cutting off the flow of electricity and preventing a fire. Thirdly, it is possible to apply antioxidant compounds. These compounds are designed to prevent corrosion of the aluminum wiring. They are applied to the connections between the aluminum wiring and the electrical devices, such as outlets and switches. Fourthly, another option is to pigtail the aluminum wiring to copper wiring at the connection points. This involves using a short length of copper wire to connect the aluminum wiring to the electrical device. The connection between the aluminum and copper wires is made using a special connector that is designed for use with dissimilar metals. Fifthly, the entire electrical system can be rewired with copper wiring. This is the most expensive option, but it is also the most effective way to eliminate the risks associated with aluminum wiring. The decision of which option is best will depend on the specific circumstances of the home, the condition of the existing wiring, and the budget of the homeowner. It is important to consult with a qualified electrician to determine the best course of action. The NEC provides guidelines and requirements for addressing aluminum wiring in existing homes. It is important to follow these guidelines to ensure that the electrical system is safe and compliant with code. The NEC also provides information on the proper installation and maintenance of electrical wiring, including copper wiring. By following these guidelines, homeowners can ensure that their electrical systems are safe and reliable. In addition to the NEC, local building codes may also have specific requirements for addressing aluminum wiring. It is important to check with the local building department to determine if there are any additional requirements. For example, some jurisdictions may require a permit to be pulled before any electrical work is performed. Others may have specific requirements for the type of connectors that can be used with aluminum wiring. It is also important to be aware of the signs of problems with aluminum wiring. These signs include flickering lights, warm outlets or switches, and the smell of burning plastic. If any of these signs are present, it is important to contact a qualified electrician immediately. Ignoring these signs can lead to a dangerous situation. Aluminum wiring can be a safe and reliable conductor if it is properly installed and maintained. However, it is important to be aware of the risks associated with aluminum wiring and to take steps to mitigate those risks. By following the guidelines in the NEC and consulting with a qualified electrician, homeowners can ensure that their electrical systems are safe and compliant with code. It is also important to be aware of the potential for future problems with aluminum wiring. Over time, aluminum wiring can become brittle and corroded, which can increase the risk of electrical fires. Therefore, it is important to have the wiring inspected regularly by a qualified electrician. The electrician can identify any potential problems and make recommendations for repairs or replacements. In conclusion, aluminum entry wiring is not permitted in new residential construction in the United States due to safety concerns. Copper wiring is now the standard. If a home has aluminum wiring, it is important to have it inspected by a qualified electrician and to take steps to mitigate the risks associated with it.